Thank you very much for coming back. We take off with a new series of questions. So you will find the different documents, whatever, on the Google Drive and on the link page I gave. So very rapidly, I try. We have three parts in this second presentation. These three parts are related to the question of characterization of extreme inequalities with new tools for the measurement of inequalities. The first part will be about rewealthization, and the second and the third will be associated with the empirical analysis of extreme inequalities. Just to begin with the question of extreme inequalities, Luxembourg income study is a very nice place to analyze the transformations of different societies, in particular the US and also South Africa, but not only, as examples of extreme cases of inequalities on the planet. I simply insist that many results you will see here had been published at the beginning of this year in a special project of the Journal of Chinese Sociology, organized with the sociologist Mike Savage of the London School of Economics. And it will be an opportunity to see very problematic questions of extreme inequalities today. Just to begin with, it's not in Luxembourg income study, but it is in everyday life. This present number of kilo euros you need to buy 1 square meter in different cities. Now, Luxembourg and Paris are almost the same, you see, but London is 16 kilo euros per square meter, and it's bad news almost everywhere. That's it. And if you want, this question is almost universal, and it's why having Luxembourg income study is nice simply because it's not only Europe plus the US. More and more data sets of the Luxembourg income study are fitting with extreme cases. This very nice graphic, you think I am cynical, but this graphic presents how many years of standard wages you need to buy a 100 square meter residence in an okay neighborhood in different cities. So in Mumbai, you need work 308 years. In London, it's only 1 century something. In Paris, Paris is relatively cheap. You just have to work 77 years and save. You must not eat and consume it. On top of that, the funny thing is that it was in 2012. And from 2012 to today, prices in Paris to plus 50%, something like that. So interesting thing is that it's not only housing wealth that becomes entirely crazy. It's also the access to selective education, health, whatsoever service that is more and more crazy. So to understand better what happens, something interesting is to think about strobiloids. Strobiloids being indeed simply the distribution of income and of wealth. Here you have an example with France. It's not in dollars, it's in euros. So it's a scale of euros with relatively recent data coming from EU HFCS for wealth and EU Silk for income. Those things had been published, and you can follow the link. The paper is in English, even if the link goes to a Russian website of the Higher School of Economics of Moscow that had a nice project on middle class dynamics. So Russia and China are extremely interested in the question of middle class transformations. But you have a nice book of Luxembourg income study edited by Janek Gornik and Marcus Yanti on this topic of middle class. And what you see on these graphs of strobiloids, when it comes to incomes, you have something, here is the median income and median wealth. On the median income distribution, it's a kind of density presented on a vertical axis. France is a middle class society, and in terms of incomes, you have something like middle class. The strobiloid of income has a large belly, where, and then this means that this belly means there is median class of people with incomes near to the median. When you compare to the US, the French median class is more dense than American median class. But when you go to wealth distribution, you have no such thing as a middle class of wealth society. So for France, the difference of distribution between a Gini index 45% and a Gini of wealth 64% is fitting with that kind of curve. When now you consider wealth through the survey of consumer finance, you have those data sets in the Luxembourg wealth survey. Here you have something interesting. So something very important to compare in this perspective is traditional. This comes from Stiglitz 1969 paper. You will find the reference in the papers I suggest. You have the wealth to income ratio. That is an indicator, an important indicator proposed by Stiglitz, Nobel Prize once again, 1969. So what you have here is through the Alvaredo, Piketty, and Friends World Income Database you can access here, and also with SSC install WID command. What you have here is the wealth to income ratio. It's expressed in years. In Austria, in the recent times, you need 7 years something of savings of the GDP to equate, you need 7 years of income to generate average wealth. You see Spain that reached the level 8 years and that declined. France is like that. At 6 years of income to generate to save average wealth, in the early 1990s, it was 50% less. And the strange evolution, extremely strange, is the one of the USA. USA is relatively low and stable. It looks like something paradoxical. It's extremely interesting. And with Luxembourg income study, we can do so. We can compute the top wealth to income ratio. This top wealth to income ratio is the average net wealth of the top 1% of country divided by the average income of this country. So here, once again, it's with Piketty, Alvaredo, etc. with data. You can replicate this with the Stata do file I circulate in the slides. What is the meaning of that? In the early 1990s, the top wealth, the average top 1% wealth average in France represented something like 55 years of average income. And now it's 120. For the US, top wealth, Gini indices of wealth in the US is extremely strong. Top wealth in the US represented 120 years in 1990, and now it's more than 200 years. You need 200 years of average income to make the average top 1% wealth in the country. And this number almost doubled across the last 30 years. You will find here do file. I put list, but indeed it lists for this session. It's not list data, it's world income database data. With the do file here and with your local Stata software, you will generate this graphic. And this graphic is extremely interesting because it comes from the early 20th century and it shows the recovery of wealth, of top wealth income ratio in France. Recovery is not entire because we would need to go back to 400 years to equate what we observed in France in the early 20th century. But if you observe the US, the recovery from the before World War I situation is back. This means that in the US, you need 200 years of average income to have the average top 1% wealth. And 200 years means that you have to save many years to reach that part. So either you're super lucky and you win at the lottery of capitalism or game or whatever, or you really have to work hard and long to reach this top wealth to income ratio, to reach top wealth. What does it mean? It means that now, if you're not an insider of the top wealth by inheritance or super lucky game in real life, it's very difficult to reach. Or conversely, if you're a member of this top wealth to income ratio part, if you are a member of the top 1% in wealth population, you can buy 2 times more time of average workers than what you had 30 years before. This is a massive message. So at some point, something that could be interesting is to compare Gini indices of wealth. I anticipate with Nora Whitecoos in 1 hour something presentation. It's interesting to compare the Gini of wealth and the top wealth to income ratio to compare the degree to which we can characterize extreme wealth inequalities. So first, and it's the first program of this second session, it's interesting to compare in scale of log dollars the shape of distribution of income that is relatively dense compared to what you have in terms of wealth distribution in a logged distribution. And the interesting thing is that top 1% wealth is here, and this expresses the top wealth to income ratio on LIS Stata based on survey of consumer finance. Now our top wealth to income ratio is 600 years. That's it. With this LISI program, you can simply obtain distribution of wealth and you can make use of the ACA density. It's a kernel density program that had been developed by Philippe Van Kerm some time ago, but it had been upgraded to several times by Philippe, so that you can have this kind of logged distributions. So on the do file, what you can see is that the example we have crunched at the end of previous session, this began at 331 and was finished at 338, so it's not too long, and you obtain the before last graphic I showed in the previous session. But right now, what we can do is session 2x1, and I will try copy paste this program, this very short, rapid program, Control A to copy, Control A, Control V to paste, we crunch, and I think this works in small number of seconds. I apologize that this program is failing stupidly. With this program, what you obtain is simply this slide distribution. This should have worked, but that's it. So more seriously, but it takes time, you have a second program here that offers the possibility to compare the Gini index of wealth to the top wealth to income ratio. Have in mind that the top wealth of income ratio is a kind of mixture of intensity of the Gini index of wealth and of the wealth to income ratio that we observe in the dataset. I mean that to be high in top wealth to income ratio, you need a top 1% category that is super high. It's a LWS project. So if you paste LWS project in a LIS window, you cannot succeed. We have the result, and with this magnificent graphic. So you see the distribution in income and the distribution of wealth. And to have a very high wealth to income ratio, you need to have super extreme power tail distribution of wealth on the right of this graphic and comparatively low average income position here. So we could replicate this program. Second program to replicate right now, second result to replicate is this graphic. We'll have no time to run it because I think it takes 40 minutes to have this graphic. But in this graphic, you have all the Luxembourg Wealth Study country year datasets. And what you have on the right of the graphic is countries with very high Gini of wealth indices. The interesting thing is that some Nordic countries, in particular Sweden, have a very high Gini index of wealth, simply because wealth is not a common resource in Nordic countries. And you have a small proportion of the population that have almost all the wealth resources of the country. Gini in Sweden is very high, but the wealth to income ratio is not high in Sweden. And this means that top wealth population in Sweden is not massively dominating the level of income of Swedish income earners. So the specific situation of Sweden is interesting because it means that high indices of wealth doesn't mean that the wealthy part of Sweden earn or dominate the Swedish incomes. Relative average incomes in Sweden are high compared to wealth accumulation of the wealthiest top 1% Swedish population. So what you see here in this graphic is that the US is extremely unequal in terms of Gini and in terms of top wealth to income ratio. And through the Luxembourg income study, you see the frightening US trajectory with more detail. What you see is from 1995 to 2007, US increased massively its Gini of wealth, but much more the top wealth to income ratio value. You have had a decline after 2008 great recession time with relatively substantial losses on the capital markets. But the recovery from 2010 to 2016 had been massive. And between 2016 and 2019, you have a confirmation of the extreme Gini of wealth and of the super extreme top wealth to income ratio in the US. So with this program that you can have access right here, if you click to the link, you have a complete program that takes something like a bit more than half an hour. I just try see if I have this example here. I search the result of the program to see the degree to which it takes hours to be executed. Okay, it is this one. So you can copy paste the program. I have executed it at noon and it took 45 minutes to be entirely executed in order to have this graphic that is on the PowerPoint. So with the help of the LIS program, you simply can replicate this graphic. And it's an opportunity to see that South Africa and the US are entirely crazy countries in terms of extreme inequalities. And I would be 30-year old. I think I would have one semester minimum in South Africa to observe the crazy situation. And American PhD candidates and young scholars are lucky, so to speak. They can observe extreme realities that are, if you have looked to the UK, Luxembourg, Italy, Spain, for countries with relatively high top wealth to income ratios, this remains relatively modest compared to US 2019 or South Africa as well. So be aware this graph is one of the many examples where Gini of wealth, massive inequalities in Norway, Germany, Sweden, Finland has a more modest Gini of wealth. Those Gini of wealth in Sweden and Norway may hide a relatively modest top wealth to income ratio. That means that the wealth accumulation of the richest Nordic Europeans is not so extreme compared to incomes in those countries. So part three for me is to try understand better how extreme inequalities of joint income and wealth distribution could have changed from 1995 to 2019 in the US through the survey of consumer finance that you find in the LIS Database project. So for a rapid outline of the working paper we are currently refreshing, it's a kind of development on how wealth to income ratio and the relation between wealth and income are extremely important to understand the real position of individuals. And something extremely difficult in this kind of literature is to understand how distributions work. If you have time, Once again, it's a kind of copyleft. I should not circulate that, but that's it. You have the Bible of distributions by Kleiber and Scott. It's K und K Sweet's Bible of distributions of income and wealth resources. And the question is, how is it possible to represent joint extreme inequality of income and wealth? So first, you all know Gini index. You have had developments by Philippe and others also to see how we come from the Lorenz curve to the Gini index. The main idea is to show the big difference between income distribution Lorenz curve in standard European countries like France, Germany, Luxembourg. The Lorenz curves are relatively similar for incomes to wealth distribution in Luxembourg, for instance, the Lorenz of wealth distribution in Luxembourg, and the completely crazy, it's a Gini wealth in Luxembourg, means a Gini index of 64%. When it comes to the US, the extreme difficulty is that we reach a level of Gini indices that is entirely difficult to conceptualize, simply because when you reach Gini index 85, you don't really know the kind of distribution you fit. And then it's clear that Gini indices are useful to have a kind of overall diagnosis, but the main issue is that we have to understand better how the top power tail, the bottom power tail, and the whole distribution of wealth can be represented. And to do so, I make use of papers that had been published 5 years ago in the Review of Income and Wealth, where I expose how it's possible to represent those, to have across the distribution representation of inequalities in this context. So to present rapidly the difficulty of Gini and of Lorenz, is that when you look to Lorenz curve, for instance, this had been published by Philippe and different colleagues, the difficulty of those curves here is that the most important part of the distribution, the bottom poor and the top rich, when you try magnify those parts of the distribution, the big changes that you can see at the top and at the bottom are not easy to read simply because with the Lorenz curves and with the Gini indices, you have a kind of saturation of information at the bottom and also at the top. You don't really see what happens when big things happen in this respect. So to understand better how we can have a general representation of what happens, it's important to change the shape of the graphics we dispose of. And one of the many useful graphics is what we call the yen-pence parade. It's a paper that had been published. There should be a link somewhere, Parade of Dwarves. The idea is to represent, for instance, from quintile 0 to top quintile 1, the income distribution. The argument here is that you can represent the percentiles from 0 to 100, and the best way to represent the thing is to represent the fractional quintile, and you have a nice command, SSC install command from Philippe to have this fractional rank from 0 to 1, and then you can represent vertically the levels of incomes. It's a kind of cumulative distribution function represented vertically. But once again, the problem with this Jan-Pence parade is that the most important thing that can happen are either at the bottom for the super poor and even more at the top for the super rich, and those curves are very difficult to compare. So something else is to be done. And when you're a sociologist who works a lot on social mobility with categorical variables, when you see percentiles between 0 and 1, the first thing you think is we need logit transformation. If you have 0 saturated and 1 saturated percentile rank distribution, the first thing that you think of when you have a 0 to 1 distribution is to logit distribution. And when you have vertical axe distribution of this kind of shape, the main idea is to log the vertical axis of medianized income, if you want, for instance, simply to see better the differences at the bottom and at the top. So here it's for wealth distribution. The Jan Pen, parade is even more super extremely distributed that way. So what we do is we logit the 0 to 1 distribution. We log the vertical axis that is typically Pareto distributed, where the log transformation is the one that makes sense. And on this base, X is the logit of fractional rank, Y is a log medianized income or wealth resource. And when you graph those XY graphics that way, when you make those transformations, since we have medianized income and medianized wealth, 0, 0 is a part of this big X, uppercase X, and uppercase Y transformations of income and wealth. And the most natural thing you see happening in this transformation is that inequality has specific level across income distribution level, ISO, Y divided by X, the ratio of log income by logit fractional rank, ISO, is almost natural when you see the curve here, measurement of inequality. The slopiest a curve that has stronger slope compared to the 0, 0 median wealth transformed in logic percentile rank. 0 is the median, and 0 for the logged median wealth or logged median income. The slopes you have here are good measurements of inequalities at this precise level of the distribution. When big X is equal to, this means that we are close to the top decile. You inverse the logit 2, you obtain 0.88. We are close to the top decile. For this graph, 0 is the median, 1 is close to top quartile, 2 to top decile, 3 to top vintile, top 5%, 4 to top 2%. And if wealth is extremely unequal, the slope will be stronger. And this is the idea of what we call the isograph. The isograph is the representation of the slope of the previous graph across the big X logit rank distribution of the quantile of the population. It's presented in this paper, and you have Isograph SSC install Isograph that is already presented. And those isographs are higher in case of extreme inequalities and lower in case of less inequalities. Just additional details. When the ISO representation is flat, this means that you have Champernon-Fiske double Pareto distribution, and it's very common for incomes. If the isograph representation is flat, you have level alpha that is exactly the Gini index of the value. It's a calculation that had been done by Degum in 1977. That is, in the isograph, when it's flat, it means that you have a Gini of that value. And if you have a slope of something like 1, you have a Gini index that is close to 1. That's the point. At the top, near to 1, you have, of course, a saturation of the value of the Gini index. So, as soon as you make use of US SCF in the Luxembourg Well Study LIS program, you have a series of surveys, 3 years intervals between each survey of some thousands of people. You have incomes and you have also marketable net wealth, net of debt. And when you do the isographs of those variables, of those wealth and income variables, with the program you will find right here, what you will see for Germany, for Finland, for Italy, for the UK, for Great Britain, for the US, and for South Africa, is that income isograph is relatively flat above the median. Below the median, wealth is almost unexisting, but above the median, income isographs are close to 0.35 in Germany, 0.35 in Finland, 0.35 again, something like that in Italy, a bit higher in the UK, near to 0.50 in the US, and close to 0.60 for the income isograph in South Africa. But when you have a look to the wealth isograph, you reach when big X is 4, we are at the 0.2%. When big X is 6, this means that you reach the top 0.5% of the distribution. What you see in Germany is that isograph is very high near to the median, but it stabilized at 0.70 something for Germany, a bit lower in Finland, even less in Italy, 0.6 in the UK. What you see with the isograph of the US and of South Africa is that you have values of 1 across the top of the distribution of USA and South Africa. This means that you have cases of super extreme inequalities that are almost impossible to describe, in particular, not with the Gini indices that have a difficulty when the isograph is close to 1, simply because the wealth of the Gini you evaluate is super extreme. Simply to finish with and have Q&A before the next session of Nora Wildkus, I just insist on the fact that you can download here working papers that had been presented in Tony Atkinson Memorial Seminar in 2018. We are updating this working paper with data not only of 2016 but of 2019, simply to show that with the isograph, we can detect a series of very problematic elements of American dynamics in terms of inequalities. Through the LWS, the American isograph of income faced very significant increase near to the top decile of the income distribution. So message number 1 on the transformation of the US is that income inequalities increased very significantly near to the top decile from 1995 to 2016. It's increasing inequalities result number 1. In terms of wealth, it's even more radical. There is an extremely important increase of wealth inequality distribution observed through the isograph element. The most important increase is near to the logit rank wealth 2, that is the top decile, until the top 0.5%, where there had been a strong increase of the gaps between the median and those percentiles of wealth. Second result regarding wealth is that from 1995 to 2016, there had been a boom in wealth inequalities in the US at those levels of the distributions. When you work on the joint distribution of income and wealth through the heat maps you can redo with the Luxembourg wealth study, you have increasing correlation between income and wealth distribution above the median in the US. That is, you have an increasing consistence of rank positions in income and in rank positions with wealth. That is, inequality of income and inequality of wealth are more and more parallel in the US. It's frightening result number 3 in this respect. You have it in terms of correlations of the logs and correlations of the logits ranks of the distribution. The results are relatively similar. There is significant increase in the correlations of income and wealth association over time. What do we have on top of that? When you compute across the diagonal of the heat map, on the heat map, you have consistent households that follow the diagonal of the logit rank of income and the logit ranks of wealth. What you observe on the wealth to income ratio on this diagonal is that you have an increasing wealth to income ratio for the population near to the diagonal of the heat map of the joint wealth to income representations. And this means that close to the top 2% of income and wealth in 1995, wealth represented 6 years of big incomes, and now wealth represents 10 years of big incomes in 2016. So the different messages in terms of extreme inequalities through the lens of the Luxembourg wealth study is that income and wealth inequalities increased significantly and massively. Above the median, wealth inequality increased almost everywhere. The very top fractiles above the top 1% are less affected. So by this increase of wealth income inequalities, is it due to the data or the reality? Question mark. Frightening result number 3 is about the association between wealth and income. Ranks of income and ranks of wealth are more and more the same. The wealth rich and the income rich are in the same household. Final result number 4 is a wealth to income ratio that increases in particular across the diagonal, meaning the richest in wealth have more and more years of income in wealth. So you have a booming extreme inequality of wealth at the top. It helps understand better why the super rich Manhattan people live in 100 floors in skyscrapers above the Mars, and why the super rich Americans want to go this week to Mars. And just to finish with, we have a very initial result that is wealth inequality in the US is completely incredible through European lens. So from R0 to R5, you have 5 synergetic aspects of increasing inequalities in the US. So it's really frightening. And if we go back to the Tony Atkinson latest work on what is to be done regarding inequalities, you see a series of proposals including annual wealth taxes and inheritance wealth taxes that are relatively vital. Indeed, just to conclude, and then I go to the Q&A. In terms of consequences, rewealthization is an extremely interesting dynamics of the last 30 years, and it's even more frightening in the US than elsewhere, but it could be frightening in China too. At some point, middle class, the wage earner middle class, and even the upper middle class of wage earners are massively excluded. We saw with housing prices from the rich city centers. Big wages are not sufficient. You need inherited wealth to live in affluent neighborhoods. In terms of housing market, we can suppose different things. And just to conclude with those extreme inequalities, you certainly know this book of Walter Scheidel, The Great Leveler, the translation in French. So the main message of Walter Scheidel would be that civilization and accumulation of inequalities are intrinsically linked one each other. The big issue is that the relative equality we have had in the 30 years after Second World War, we call that in different countries, Miracolo Economico in Italian, Wirtschaftswunder, Trente Glorieuses, Golden Age in the US and the UK. This period of Western Golden Age of relative containment of extreme inequalities is now over. The risky message of Walter Scheidel is that civilization is intrinsically associated with a risk of accumulation of inequalities. And the main message of Walter Scheidel in his book is that if you want to reduce massive inequalities, you have the choice between 4 different disruptions that are, for Walter Scheidel, massive revolutions, collapse of the state, total war, not a small war, but world wars, or massive pandemic with mortality rates 5 or 10 or more percent. In that kind of event, he has, as a historian, he has observed a reduction of inequalities. But outside massive pandemic, revolution, collapse of the state, or war, stability of inequality is the most probable result. The issue for us in this century is that we are facing an accumulation of extreme inequalities. The US is a frightening and extremely interesting case in this respect. And this respect, LIS and LWS are very important places and steps for the science of inequalities. So thank you very much for your patience. And in the question and answer, what I see is how can we interpret the values of the y-axis? I understand they are in log medianized wealth, but what does it mean to have a value of 1 or more or less? So if we go back to, for instance, what kind of example we can make use of? So this is an isograph of wealth. 0 is the median, 2 is close to the top 1%, 2 means top 10%, 4 means top 5% or 2%, and 5.5 is top 0.5%. Indeed, the higher the isograph, the higher inequality. And I go here, for instance, in Germany, you see the income isograph is close to 0.30 something, near to 0.35. Indeed, the Gini index of income for Germany is close to 35%. Indeed, the isograph of income, when it's flat at 0.35%, the Gini index of income ici, here, Gini income is 35%. It's a result of Dagum. When the isograph is flat, the Gini index is flat. What we have here, for instance, for German wealth, we should find German wealth value here. Indeed. Let's search for German wealth Gini 2017. We have the value of this German wealth Gini somewhere on this graph. Gini index wealth. Germany up is here, so 0.74 or 0.73. This is the value of the Gini index for Germany. This means Gini, you can express the Gini in percentage, 74% is equal Gini wealth for Germany. That's it, 74. So here the Gini index for Germany is the tangent of the isograph in higher values of big X here. So Gini wealth DE is close to 0.75. It's what we have. You can try see this systematically. When the maximum value of the isograph is not too high, Gini and the isograph are supposed or the same. If you want to see the Gini index of income for Finland, it's 0.30 something here. And for the Gini of Finland for wealth, it will be 0.55, something like that. The real problem is for the US and South Africa, and it's a question of Diana Garcia Rojas in the Q&A. What does it mean to be above 1 for the isograph? This means that we are at the threshold of saturation, where the value of the Gini index has great difficulties to measure out transformations of extreme inequalities. And the message of the isograph here with values above 1 is that we are not far away from what we call the zip distribution. The zip distribution is a super extreme Pareto distribution, and you can document this with the K and K Bible. The zip distribution that we call sometimes the Pharaoh distribution is this kind of extreme Pareto distribution. Imagine that at the bottom level imagine a pyramid where the slaves are 10 millions at level -8 and earn 1. You have then in a zip distribution, you have 1 million of non-slave peasants at level income 10. And you have 10 times smaller group of craftsmen at level 100. And then you have a kind of order where at the top you have the pharaoh that is 10 times higher than the lowest government official group, that are 10 times higher in resources, and each subaltern group is 10 times larger. It's precisely it's theoretical. The zip distribution is based on distributions where 10 times smaller group above earns 10 times larger incomes. The problem with this zip distribution is that we enter in a domain of Pareto distributions with super extreme. The integral of level of incomes in the group from 0 to infinite. The average income formula diverge, and we have a situation with super extreme non-convergent inequalities, with saturation of the Gini and declining possibility to describe inequalities. Other small detail I should provide here is that on the isograph, what we observe also in those distributions is that, for instance, for Germany, the isograph near to the median is super extreme, and it's something we observe in many different countries. This means that median wealth in some countries, median wealth is no longer defined, or median wealth can be negative in some countries, such as, for instance, Sweden, if you want, simply because majority of the population has small debt, but a debt. You have increasing difficulties to measure out inequalities in a context where median wealth is no longer loggable. You cannot log median income because it's a negative value. And this is a problem with many measures of inequalities. In the Q&A session, I see also, would you recommend any additional piece of work that would help us understand how the pandemic could affect inequality? For example, previous cases of events that affected inequality. You have a huge development of the literature connected with extreme inequality and COVID-19. I would say that right now, I don't have in mind the answer to your question, but if you let me search in my recent archives of books, of reports, I mean, so you have my email. Please send me back your question regarding additional piece of work regarding the recent wealth and income dynamics. I will be happy to answer. What we know is that with quantitative easing policies, there had been a massive trend of wealth asset inflation. That is, square meters, the price of square meters in Luxembourg is 25% higher now than before the pandemic. In Paris, it's the same rate of development. We have a general situation of booming top wealth resources that certainly have a huge effect in this respect. But I know there is a debate in this respect. I've been said that Branko Milanovic believes at some point the pandemic will reduce inequalities, but I suspect Branko is extremely optimistic, and I'm not like Branko. For instance, Branko observes a reduction of world inequalities in terms of income over the last 40 years. If you include wealth, the conclusion could be very different across the last 30 years. And what we know also is that the median of income distribution and the median of wealth distribution in the world is China. With the booming Chinese economy, you have an increasing gap between China, the median of the world at this stage, and Africa, sub-Saharan Africa. And in terms of income and in terms of wealth, the distance between the median of the world that is skyrocketing to the top and stagnating poor Africa, there is an increasing relative poverty gap between Africa and the median of the world. And in this context, I don't really see how it's possible to speak of declining inequalities. But I suspect COVID-19 is at first an accelerator of the trends we observed over the last 30 years. It is what I guess. So if you have other questions, do not hesitate to step in. Zoom is not necessarily the most interactive place because I don't see you, and it's difficult to feel the atmosphere of enthusiasm regarding extreme inequalities. But it's clear that extreme inequalities will continue to be the hot topic of the social sciences, of social stratification, social policies, global analysis of transformation, comparative sociology, and economics of transformation. And Luxembourg Income Study is a very nice place to try run different programs. And WebWE is this is a super cool opportunity to generate crazy graphics. I will simply try find different graphics I made in the recent times. It's not the most beautiful graphic you could imagine. What I did for the Atkinson conference is certainly nicer. This series of heat map, I try redo it in a comparative perspective. This series of density maps of joint income and rails is not the best one, but you just have to see. Could you repeat the link for finding the material? Thanks. I just try. So you have the Google Drive provided earlier by Heba. If you go to the chat, Control C, and then I try open myself this link. If you go, what I will try to do in the next days will be to refresh the link. I will update the programs, the Stata programs, so that you can replicate on your own the new working paper that is showing the 5 bad news of increasing inequalities in the US. Could you go over the interpretation of the graphic on slide 34? I can send you an email later about this, and I understand it's a long topic. The long topic being many things. Some researchers go for excluding those outliers, but it was wonderful how right that is. Indeed, with the isograph, it's not only one. With a Pareto graph, you can redraw the outliers. I mean that at some point you see you have a kind of continuous curve with a monotonic slope. So on this base, you can redraw the top individuals with outlier positions so that you can re-smooth with an algorithm or manually if you believe in your own capacity to smooth this kind of curve. But the complete isograph provides the complete information too. So it's relatively convenient to see when you have shaky results that are no longer robust, stable, reliable, whatever the word. So for Fiorella Para Murica, if you're from Spanish-speaking country, sorry for my pronunciation if not, we can discuss that, but the isograph provides the possibility to have arguments regarding the outliers, to know what is to be not done with outliers. So that's it. You will think that I prefer super complicated graphics to super simple graphics. Indeed, those graphics are based on logit ranks. That is, 0 is the median of income, 2 is top 10%, 4 is top 5%, if I'm not wrong, I've forgotten, 6 is top 2%, maybe. And you logit rank, it's a rank graph, but as we know, the problem when you go to the top 1 rank fractile distribution, when you go to 1, you're near to the saturation. In this group near to 1 in terms of fractile ranks, you have a saturation with no difference between simple millionaires and multi-billionaires. When you're in a standard, not non-logited rank graph, you have a big extreme density here that aggregates top billionaires with standard millionaires, if you want. As soon as you logit rank, you have a better distribution that you can represent as density curve, a two-dimensional density curve. We call that a heat map. And Ben Yan, the author of SSC Install Heat Map, provides a very nice way to represent those heat maps of density. And what we see is that on the diagonal of the rank or logit rank of income and wealth, you have an increasingly dense part of the population. That means income rich and wealth rich are more and more the same, and you have a smaller choice in the distribution. I don't represent below the median because below the median of wealth is really super nothing. So I did not represent it. I simply represent in the median class to the upper the median class to very rich people and so on, the consistence of income and wealth positions that can help simulate the values of wealth and income in this respect. I hope I was sufficiently clear regarding those ugly representations. Be aware simply that those representations are extremely interesting to catch better the complexity of the relation of incomes and wealth. Simply the general message is those heat maps are not heat maps, it's density curves, okay, but what we see, the interest of this specific graph, for instance, is to show that in terms of logit rank, the consistence in Germany or Italy is much less radical than in the US. The correlation in the US in logit rank of income and logit rank of wealth is much stronger than elsewhere in the world. It's one of the messages you can see here. Are there other questions? I will circulate more detailed WebWe programs so that you can have more fun with those joint representations. So thank you very much for your patience. See you.